Let us take a look at what problem 1.3 is about. We are asked to study the contribution payment stream C and a benefit payment stream B. So let us draw our setup. I have a contribution payment stream that looks something like this. So if I have my timeline here, then the payments at time 0 is just 0. So if I draw C of t along this line, then I can see that from time 1 up until time k, so 1, 2, up until time k, then at each time point there is a payment of pi. So the size of each of these payments up until time k is pi. And by pi we don't mean 3.14, but just it is a symbol that we use often to denote premium or just price. So it's a symbol and not a number. And then we go on. After the kth payment, we just have zeros. So at time k plus 1 up until time n, the payments are just non-existent for the contribution payment stream. Now let me draw up the benefit payment stream. So we can see the benefit payment stream has payments at other time points than the contribution payment stream, in the sense that from time 0 up until time k, everything is just 0. We can see that here by the zeros we see here. And then from time k plus 1, sorry, I should have a k plus n up here, yeah, until time k plus n, we have a payment of 1 unit at each time point. So this is how our payments look. Now, what are we asked to do in this exercise? It's always a good idea to read which things we have to do in an exercise, because often it's not that clear. So it's a good idea to write a list just so that you're sure of it. So we have to determine v of t for 2 different cases, one for t greater than equal to k and one for t smaller than k. So determine v of t for t greater than equal to k and for t smaller than k, respectively. And the reason why we look at these 2 different scenarios is because, well, quite clearly something special goes on at time k. So if you do not remember what v of t is, it is the discounted present value at time t of the future net benefits. So try to just listen to that again if you need to catch up on that, or else we'll go through the definition and formula for that later as well. So no worries. And then 2, we have to show in particular that v of 0 is equal to the initial present value of a deferred annuity in arrear minus pi multiplied by the initial present value of an annuity in arrear spanning k time periods. And furthermore, we are also asked to calculate pi. So find the value of pi such that fairness is fulfilled. So calculate pi. So fairness holds. And If you can't remember fairness, that's okay. We'll talk about that in just a moment as well. And then 4, calculate pi with those numerical values there. So with numbers, I'll just write. And there's more. We also want to look at a continuous time version where we, instead of lump sum payments, have payment rates that are given by this expression here. And then we also want to calculate pi. So the last part, and I'll just like kind of make a line here to note that now we're over in the continuous case. So we want to calculate pi. So fairness holds in the continuous case. Wow, there is really a lot of stuff we want to do in this exercise, it seems. Because after this, we also want to plug in the numbers as well. So what we have to do now, what I would ask you to do on your own as well, is to take each of these things that you're looking at and find their definitions in the book. So simply just write up a whole list where you write up the definitions of these. I will do that as well, not on camera, but I will write that up over here just in a second. And we will have that for our later calculations. So do that on your own for this and this and this and this, and also write down the fairness criterion. And let me see what else. Oh yeah, also write down the definition of v of t in both the continuous case down here and the discrete case up here. And then we will go on to talking about how to solve this.